Oh, crrr. Oh, crrr. Oh, crrr. Oh, crrr. Meow. Meow. Hey guys, welcome back to the vlog. My name's Lauren.
My name's Olivia.
And we're going to be showing you a day in our lives.
The first thing we do when we get up is brush our teeth.
I want to know how many moles of mouthwash I use every morning.
Mole is a unit for measuring large quantities of very small things, such as atoms, molecules, or other specific particles.
Mole is 6.02 times 10 to the 23rd, and it was created by Avogadro. This crust has a chemical formula of C30H52O3, which has a molar mass of 460 grams per mole.
I am only using 50 grams of mouthwash though, so that means I'm using 0.1086 moles of mouthwash in the morning.
Now we're going to go downstairs and make pancakes. We're about to get ready for school, but we wanted to tell you how we made our pancakes.
Measurement's an important part of chemistry and baking. We need to measure ingredients to ensure that we have the right amount of each ingredient so that they can react together correctly to make the best tasting pancakes.
We used 2 cups of milk, or 473.8 milliliters.
We wanted to know how many microliters of milk this is, so we need to convert milliliters to microliters.
We also used 1 tablespoon of sugar, or about 14.79 milliliters. We wanted to know how many nanoliters of sugar is used.
Being able to convert measurements in the metric system is important to allow us to ensure that we're using the best unit for our experiment or making pancakes.
Say if I was making a very large quantity of pancakes, it would be much more efficient to measure my ingredients in a larger unit, such as kilograms or kiloliters.
But because we're making a small amount of pancakes, it's much more efficient to use a smaller unit, such as milli or micro. And measurements are important in everything we do, and that's why it's so important to use accurate measurements, especially when you're doing more precise sciences.
The measurements would need to be much more precise in something such as medicine compared to cooking. Now we're going to get ready for school, and we're going to explain the physical and chemical changes of our pancakes.
A physical change is a change affecting the form of the chemical substance, so that means it can be reversed.
A chemical change is usually an irreversible chemical reaction involving the rearrangement of the atoms of one or more substance and a change in their chemical properties or composition, resulting in the formation of at least one new substance.
So mixing the dry ingredients together is a physical change, as well as adding water to the mixture and chewing the pancake.
When we cook the pancakes, that's a chemical change because there's a change in the color, there's a change in odor, and the formation of bubbles, and an intake in heat.
Another chemical reaction is when we digest the food, because the food is being broken up and decomposed, so that means it's irreversible.
Hey guys, what's up? We're going to talk about our breakfast.
Like what ingredients we used and what they're composed of.
Well, we use salt, which is NaCl, or sodium chloride.
Sodium chloride is an ionic bond, meaning one element is a cation, the sodium, and the other is an anion, the chlorine.
Sodium has a charge of +1, and chlorine has a charge of -1, so it's balanced. And the ending of the anion is changed to "ide", so it's sodium chloride.
Another ingredient we use is baking soda.
And baking soda has a chemical formula of NaHCO3. This is also an ionic bond, but there's a polyatomic ion.
The polyatomic ion is bicarbonate, or HCO3, and it's bonded with sodium. Sodium has a charge of +1, but bicarbonate has a charge of -1, so it's balanced, and that's why it's called sodium bicarbonate.
We'll see you after school.
We just got back and we're about to make some Kool-Aid, but first, what is Kool-Aid?
Kool-Aid's a solution which is a homogeneous mixture that has a constant composition throughout.
In this case, our solvent, or the thing being dissolved, is our Kool-Aid mixture.
Our solute, the thing that's present in a greater amount, is our water.
We're making 240 milliliters of Kool-Aid, and we know that we want to make Kool-Aid with a molarity of 0.7.
We need to know how many grams of Kool-Aid to add using the formula M equals moles divided by liters. We know that to find how many moles of Kool-Aid we need, we multiply by the molarity, which is 0.7, times the liters of the solution, which is 0.24 liters, because we have 240 milliliters.
This means we need 0.168 moles of Kool-Aid, and because the molar mass of Kool-Aid is 342 grams, we need 57.456 grams of Kool-Aid.
I like my Kool-Aid weaker, so I need to dilute my solution. To do this, we decrease the concentration of the solution.
The molarity of this new solution is 0.4, so when we multiply this by 0.24 liters of water, we learn that we need 0.096 moles of Kool-Aid, which is about 32.832 grams of Kool-Aid.
Sometimes, on colder nights like tonight, we use the fireplace.
The fire is the result of combustion.
The combustion is usually a rapid chemical process that produces heat and usually light.
It involves a compound containing carbon and hydrogen, and sometimes oxygen, combining with oxygen to produce carbon dioxide and water.
In our fireplace, this process occurs between the oxygen in the air and the fuel for the fireplace.
The products are CO2 and H2O, and it also releases heat and light.
That means that this is an exothermic reaction and heat is released.